So from there, the equation, we transform now the x and y axis by rotating it in amount of pi over 4. So from here, x equal to 0, the transform equation will now be equal to x prime equal to y prime, and y equal to 10 will be equal to y prime equal to 10 square root of 2 minus x prime. And as I mentioned a while ago, the line y equal to x plus 5 will be y prime 5 square root of 2 all over 2. So by using the disk method, we're going to have the radius. Actually, we will have, I apply symmetry. I just get the volume from this part up to this part by applying symmetry. Anyway, if we're going to get the volume from that part and that part, we will have the same volume. So the new limits of integration will be, oh, by the way, xy is transformed to, that will be the transformation. Since our theta is pi over 4, so we will get those values. So the volume obtained through the disk method is given by two pi times the integral of y prime squared dx prime, where y prime, the radius, will be equal to x prime minus 5 squared root of 2 all over 2. Okay? And therefore, the volume will be equal to 125 squared root of 2 over 6 pi cubic units. And it was confirmed by applying the Papp's theorem. Okay? I get the same value applying the theorem. And this will be the next example. Consider a parabola bounded by, you have y equal to 5x minus x squared and y equal to x. And I rotated the xy axis in x prime, y prime. So the new axis of rotation will now overlap with the x prime axis. So to find the volume, I use also the disk method, so therefore I'm going to have a vertical strip or a vertical lamina, and the radius will be the y of the parabola minus the axis of rotation. But in this particular example, if you are to transform the parabola in terms of the new axis of, in terms of x prime, y prime, the resulting equation will have an xy, y prime term. Hence, we cannot express y prime in terms of x prime. So, to integrate the volume, I choose, take note that in my example, I rotate it in terms of, I use pi over 4, so that the transformation will be easier. I choose y equal to x plus 5 and y equal to x. Okay? So as I had mentioned a while ago, the equation of the parabola when transformed to x prime y prime will have x prime y prime term. Hence it cannot be explicitly expressed, that is y prime in terms of x prime. Okay? Not unlike in the first example wherein we have y prime, we could automatically express y prime in terms of x prime. In this particular example, we have a term consisting of x prime, y prime. So, to differentiate, to integrate this, I express x prime and y prime in terms of xy coordinates, and then I integrated it in this way. So the volume now will be equal to 256 square root of 2 pi all over 15. And this is, I used the Papp's theorem and I got the same result. That's all. My talk is just a simple paper.